So we have amongst us Mr. Manish Kumar Singh, who's President and Plant Head, Prism Johnson Limited, and Dr. Roger Meier, who's General Manager, Business Development, EMEA, CIS and India, FCT, ACTech. Now, without further ado, I would request the Chairman to start the proceedings. Sir?
Yeah, good evening, everybody. Presence has thinned down, but now it's a very important session, and could have been better if there were more audience, because since morning we have been talking about the net zero resultants and other things, but it is the equipment which will make it happen into the reality, into the plant, where we are doing a lot of research work, a lot of activities which are on the way, and then we need the equipment which can make our all the passion and the dreams come true. So in that particular sense, it's a very important session. So let us start that, because we are already too late. We shall have 7 presentations in the session, and because of the dearth of the time, it's a request to all the presenters to limit their time for the 7 minutes. Of course, we will consider 1 or 2 minutes more. We will go by start off first, that is inside the VRM concept as a holistic approach by Mr. Thomas Smith and Marcus Hashish by Tyson. Please.
Yeah, thank you. Thank you, Mr. Singh. Unfortunately, Dr. Thomas Schmitz is currently not available, so therefore I take the liberty to present the holistic view on our quadruple concept. My name is Stefan Dienenhofen. I'm working in the grinding department of Dr. Schmitz. And if we talk about holistic view, that means that we don't focus only on the VRM design, that we also look on the complete grinding plant, the implementation of in an integrated cement plant, as well as on maintenance aspects, availability, and also digitalization. We as Polysus, we are a full range supplier for the cement industry, and our quadruple mills for raw material grinding, cement and coal grinding, we often install within integrated cement plants. Some references are mentioned on the left, from 3,000 tons per day up to 10,000 tons per day by Yamama Cement in Saudi Arabia. And the picture above shows a typical arrangement of our quadruple concept. That means we have got a service tower, the mill itself, and also the filter dedusting. On this slide, some advantages of our quadruple mill are mentioned. For example, as a roll unit, we have less moving parts and optimized mechanical design. And we have only 1 hydraulic cylinder and 1 piston accumulator per roll unit. No tie rods are required, no confining seal air or confining air, and we have no sensors installed inside the mill. And the mill will be, or mill configuration will be according, for example, of the feed material. That means it will be, we have an adaptation for water injection, table speed, and the required gas flow for separation and drying. Also on the left picture, you can see that we have an excellent accessibility for inspection and maintenance, and no scaffolding is required. Some main features of the quadruple concept, or the main feature of the quadruple concept, are our concrete pylons. And the concrete pylons allows that the roller unit is not connected to the housing. The stopper the stopper below the roller axle ensures that we have no contact between rollers and table liner. The stopper is arranged in the same direction of the hydraulic cylinder, and all loads are transmitted in vertical direction into the pylons. The concrete pylons absorb the forces and the loads, and therefore the foundation design, or for the design of the pylons, reinforcement and post-tensioning is required. But the benefit is a smooth running of the mill at the highest availability. Here you can see some information about the improvement also of the erection of the mill. The left picture shows the typical arrangement of the 4 pylons. The right picture shows there's the installed gearbox that is pushed between the pylons, and a grinding table will be mounted on top of the gearbox. Afterwards, the separator housing or mill housing, separator housing will be installed, and finally the roll units will be lifted up to the pylons. And we have a very high pre-assembly rate of our equipment, so it means with the roll units we roughly install 50% of the total weight of the mill of the separator. That means we have less site assembly, we have less alignment work, less welding, and also less crane hours. The planned maintenance of a vertical roller mill is one of the main drivers for mill downtimes, and therefore optimized maintenance concept is also in the main focus. Planned maintenance works includes inspection, servicing, repairs, and improvements. We need a design which allows regular visual inspections. No extensive scaffolding is required. And main work of replacement wear parts are the change out of grinding table segments and roller tires, which can be, in case of roller tires, which can be done on the pylon. In the meantime, digitalization is a must for improving of availability, productivity, and also for predictive maintenance. And our quadruple mill we can install with an advanced mill controller, and the advanced mill controller automatically increase the throughput to a maximum, but also considered or monitored all the values and keep it in the loud range, that we avoid any overloads of the equipment. On the right side, you can see a graph with the mill operation without the advanced mill controller. It's in the gray color, and with the advanced mill controller. And you'll see that we have an increase in stable production of approximately 10 to 20%. And this also leads to reduction of specific power consumption and also water injection. And this was a big issue from the presentation before, that we save neutral resources. With the digitalization or the installation of a digitalization, also the support of the local operators is possible. And with the improvement of availability, we also increase the OPEX of the plant. Coming now to 2 references of the from ours. One is Cementos Progreso, where we have got 2 quadruple mills for cement grinding in one 4,500 cement plants, and there we also achieve roughly 10% more in capacity, and roughly 10% less in the specific power consumption. Another reference is the EMEA cement, where we have got two 10,000 tons per day plant, in total 4 raw mills, each with 425 tons per hour warranted capacity, and during performance test, also more than 10% higher capacity was achieved. Although we have a very dry and very fine feed material, and the water injection could be reduced to less than 0.8%. So coming now to the conclusion, a short summary of the main advantages. We have roughly 50% pre-assembled equipment with our quadruple mill and separator. We have a simple hydraulic system with only one piston accumulator, one hydraulic cylinder, one roller bearing. Roller lubrication will be done only by one pump, one oil pump, return flows by gravity. Gearbox protection, because force is only in vertical direction, less assembly, less alignment, less welding, and no extensive scaffolding during maintenance. Okay. Thank you very much for your attention.
Thank you. Thanks for sharing us with the latest developments on what is happening inside the VRM, and which is more pertinent nowadays because we are looking for reduced heat consumption by the vertical rolling mills as everybody is approaching for the waste heat recovery system and others. So that is very relevant to us. Now let us move on to the next, that is study on performance improvement on calciners using CFD by Mr. Basavaraj from Aditya Birla, Science and Technology.
Respected Chairman, Co-Chairman, and NCB member, all my delegates and my dear friends, good evening to all. Myself, Basavaraj from Aditya Birla, Science and Technology. Today, I am here to discuss one of the case study on calciner. About Aditya Birla Science and Technology, it's a corporate R&D business of Aditya Birla Group. Here, the key businesses are metal, cements, pulp and fiber, and carbon black. At ABSTC, we have strong expertise on CFD modeling and simulations, handling multi-phase systems and complex reactions. Also, we have a solid handling system capability. At ABSTC, we have a multi-purpose pilot scale facility to test high temperature reactions. We have also analytical facility to test the quality of the material. Coming to the main outline of the presentation, here I will be covering the background, the problem definitions, the CFD methodology and its framework, the area of optimization, and lastly, result and discussion. This is a typical process flow diagram for the calciner. Here, the main process of the calciner is to calcine CO3 into CaO and CO2. The efficiency of the calciner is around 90 to 95%. The main advantage of the calciner is to reduce the heat load on the kiln and also the size of rotary kiln. About the problem definitions, so one of our SLC line calciner of our plant was facing a high temperature variation at the calciner outlet. So this variation was leading to one of the major problem of coating formation at the outlet of the calciner. This coating formation lead to high energy losses and also the production losses. Having said that, the problem definition, we have used a CFD platform to understand the flow dynamics and also the mixing process and to analyze its efficiency of the calciner. I'll just go through this slide. This is our typical approach to any of the problem. Here we collect the process data and the CAD data at the site. Once the data is collected, we put into CFD modeling and the optimization studies are carried out. This is a typical CFD framework where these are the typical settings and boundary conditions which we have used for our CFD model. So here it involves some species transfer modeling, calcination and combustion reactions, a turbulence model K epsilon, and the mesh size was around 1 million. Further, this model was validated with the plant data. Here, there is a velocity profile showing the front view and side view of the calciner. On analyzing, it was found that the top section of the calciner was completely unutilized. It was also showing the high velocity and low velocity zones at the top of calciner. Further, the streamlines were plotted on the calciner. It was clearly showing that there is a short circuiting happening at the mouth of the calciner. So these two indications were enough to understand there is something problem at the outlet of the calciner. Further, the temperature plots were plotted on the calciner. Both front view and side view were showing high and low velocity profiles. Here, if you see, there's a marking done showing the high temperature patch near the slope of the outlet. Further, this model was validated with the calcination happening inside the calciner, outlet temperature, and the CO generation. Based on the study done on CFD modeling, we have tried out various aspects and various design modification at the calciner outlet. The right-hand figure shows the existing design having the very steep angle of the outlet, which was around 52. So various design modifications were done here, and the angle was adjusted to 33. Here, the slope of the outlet was lifted up. Again, this model was rerun and compared with the existing validated case. Here, there is a velocity contour profiles which are showing the comparison between existing and the modified case. If you see the modified case, it has shown that the velocity profiles are completely improved at the top section of the calciner. Similarly, the velocity streamlines were also showing that there is a proper distribution happening at the top of the calciner. This ensures there is less variability at the outlet of calciner, which will improve the calcination process. Similar profile was plotted for a temperature contour. Here, if you see, the temperature at the outlet was shifted to another side of the wall, which ensures the proper combustion inside the calciner. Hence, the temperature variation was halfly reduced from the existing case. From side view, if you also see, the profiles were well within the calciner range. So this proposed implementation was done at site, and the benefits were recorded back. Here, the benefits were seen in terms of the temperature drop on the preheater side, the outlet gas temperature, and also the specific heat was reduced by 1.8 kilocalorie per kg clinker. Other intangible benefits were complete mitigation on coating formation at the calciner outlet, smooth operation of kiln, and reduction in shutdown jobs. With this, I would like to thank you, the UltraTech plant team, to conducting this study, TPMC team, UltraTech R&D, and ABSTC team. Thank you.
Thank you, Basko, for in-time summarization and very interesting study, because CFD has become the requirement of time for every plant in the entire pyro section, and particularly with the advent of waste heat recovery systems, that also becomes necessary to check the entire waste heat recovery system profile as well. So thanks once again for the interesting case study.
Thank you, sir.
Thank you. So let us move to the third, that is in-house fabrication and erection of primary hammer crusher by J.K. Siroi, Mr. Rajesh Keswani.
Good evening, eminent panelists, my colleagues. I am Rajesh Keswani representing J.K. Lakshmi Cement Sirohi. Here I will be sharing with you one of the jobs which has been carried out in our power plant. Before proceeding further, I would like to inform you that the design basis for any coal handling plant is the coal which is being used, and our design was with use of pet coke. Here the maximum coal size was 20 mm with only 35% greater than 6 mm and 16% less than 1 mm. So our design basis led to the formation of secondary crusher in accordance with vibrating screen. The turning point was when the pet coke was banned by Honorable Supreme Court. Then we had to switch over to Indonesian and South African coal. Here the coal size was 50 mm with 50% greater than 6 mm and only 6% less than 1 mm. Now I'll explain the working of the vibrating screen. The vibrating screen basically isolates the raw coal of plus 6 mm and minus 6 mm size. The minus 6 mm is directly fed to the boiler and plus 6 mm is returned to the secondary crusher for further size reduction. Now, as our coal was changed, we started facing problems. The quantity of fines reduced, reduction led to reduction in output. The recirculation towards secondary crusher increased. Our coal handling plant running hours increased. There was a frequent damage to screen because of the large size of coal, leading to surge in breakdown hours. And when the vibrating screen was being damaged, the large particle coal went to the PL line, leading to its jamming, and finally the mismatch in power supply and demand from our power plant. We sat together and came out with a solution of introducing a primary crusher. Now, once this was decided, there were some prerequisites to be taken care of. First was we could not manage the long shutdown of the power plant. Therefore, whatever system we had to design, it should have been integrated with existing circuit, leading to non-hindrance to the running plant. Then flexibility of switching to original circuit if we did any maintenance in the primary crusher, minimum hookup time, and optimized expenses. For this implementation, there were some basic process to be followed. Civil designing was carried out with our partners. Fabrication of the crusher body was done in-house. Designing of crusher liner and hammers. This was done with the help of our stakeholder. We provided them what is the material, what is the analysis of the coal, and as it was a bought out item, therefore it had to be bought out from them. The entire erection of the new equipment was done in-house in JK Lakshmi Cement. Fabrication of the coal hopper, push feeder, we had one available with us. We refurbished it and utilized it. Then the belt conveyor, the entire structure of the belt conveyor was fabricated in-house, and hammer crusher. This, you can see, we had to make a separate hopper, and from there push feeder, and from push feeder a belt conveyor, and directly to the hammer crusher. This output of the hammer crusher was directly sent to the existing belt conveyor. So this part was entirely separate, and this was done separately, and only thing was the stoppage time of 8 hours was taken, where the material was put into the existing belt conveyor. These are some of the glimpses of the crusher. Once this was done, we could not stop there. We then decided why to use a secondary crusher at all. We stopped the secondary crusher put a new belt conveyor and took the entire output of the vibrating screen more than 6 mm directly to the primary crusher, so that there was a running of only one crusher instead of two crushers. These are some of the tangible and intangible benefits. We could reduce our coal handling plant by about 2.8 hours. Power consumption was reduced, and so the carbon footprints. The vibrating screen life was increased from 15 days to 6 months. Reduction in PL line jamming, that was obvious, and ease in switchover to existing circuit. If there was any maintenance to be carried out in primary crusher, we could easily switch over to the original circuit. But you will be surprised to know that once the crusher was installed, we have been running it since then, and there has been no substantial wear of the hammer which has been observed. Routine checks of other equipment is being carried out with no major expenses. Thanks.
Thanks, Rajesh. These are the examples when the plant people rose to the occasion and helped in achieving the targets. Thanks. So let's move to the fourth, that is a recent trends in Indian cement industry by Mr. Demla of HWI.
Respected chairman, co-chairman, and respected delegates. So, topic of my presentation is recent and green trends in cement industry. So, in this regard, I think coming to the trends, first trend is we are going for large cement plants, whereas the pros of the large cement plants are low investment, one-time statutory approvals, clearances, installation of utilities is less, so manpower is also less, investment rates and shorter payback. But cons are we want a plant which is reliable and its availability should be good. So we have been providing solution for 3 to 4 million ton capacity plants, and this is because there is a growing market and we need larger plants. So what are the trends in efficient pyro processing with respect to low carbon impact? One is on selection of calciner technology. We need now more retention time in the calciner. So we have different solutions of calciner, right from normal calciner to extended calciner where AFR can be used. So AFR, if we are to use, we have to see that we are choosing the right type of calciner for this application. So that is one recent trend. Whenever we are choosing the calciner, we have to be particular. Then we have to also look for electrical energy saving, where we need low pressure cyclones. So we are ready with the low pressure cyclone technologies, where we are talking about pressure drop of 350 mm water gauge across the 6-stage preheaters and temperatures up to 260 degrees centigrade. Coming to on the cooler side, there are a lot of improvements in the static zone. We have special plates nowadays, and in the sealing system of the cooler, wherever we have latest coolers, we have metallic sealings, and they are improving on these sides to increase the cooler efficiency. Another trend is to generate the power consumption from the cooler as well as from the preheater side. So for that, we have a solution that we have air recirculation in the cooler, which gives much better WHR capacity. So in one of the plant of 8,000 TPD, we are generating almost 15 megawatt power. So that serves almost 80% of the power consumption up to the pyro. If up to pyro, you are consuming 45 or 50 kilowatt. So you can generate almost 80% of the power through efficient WHR system. So that serves a lot of saving in the electrical energy. Coming to alternate raw materials, I think some of my colleagues have already talked about the various alternative raw materials. In one of the plant in Russia, the client is using copper slag, which has 30% substitution rate, and there is some heat in these type of raw materials, and the heat consumption comes down to 600 kilocalorie per kg clinker. But in India, still in the raw material, we have very less usage, like we are talking about slag and all. Trends on environment impact, then we have at present alternate fuel. I think a lot of things have been talked. We have substitution rate on an average around 6%. Some plants are using high rate also. In Europe, the average is 40 TSR, and in some plants it is even 90%. So 85, 90%. We have to go a very long way. I think a lot of papers will be on this aspect. Just to mention that this is one big area where we can increase the substitution rate and we can have low carbon footprints. Towards decarbonization, I think one of the talk is going on in LC3 cement, where KHD has flash calciner, where we can generate say calcined clay, which can be mixed. I think BIS and NCB is already working on these aspects to have a cement which has around 30% calcined clay, LC3. Then another trend is how to generate low NOx from environment point of view. We have a solution, pyroredox, which will be deliberated in tomorrow's session also. It is a primary step, not the secondary step of injecting ammonia. So through the process itself, there is a possibility to control NOx in the system. And then we are supplying pyrojet burner, which is a low NOx burner. So that is another important equipment. And of course, we can take care of low NOx in calciner with extended duct. Grinding systems, a lot of attention is being given towards the optimization of layout so that we have environment friendly layout as well as we have low power consumption. Like roller press, these three circuits are shown. One is normal circuit, we call it complex, which is given by KHD, and second is called complex compact, third is grind C. So these are solutions for raw material grinding, cement grinding, as well as slag grinding. Operational plants, there is a lot of possibility of upgrading and modernizing existing setup. So utilization of existing kiln to the maximum potential, that always saves the radiation energy. So we can save some 5-7 kilocalorie if we are optimizing or taking the maximum benefit. We talk about 670 or 675 kilocalorie in some of the plants. Why? Because they are utilizing maximum of the kiln capacity as well as they have very low preheater radiation losses apart from normal operation. Then availability and reliability also has a consequence on heat consumption, so as well as power consumption. So on operation side, we have to improve reliability, availability through optimization, through automation, and through these various aspects. So process optimization, preheater cyclone modification. Old plants can always go for the better designs of cyclones and optimize dip tubes and riser ducts and high efficiency top cyclones, which will ultimately come to the low carbon. Coming to digitization and automation, after the COVID period, we have been talking about connect, maintain and produce. That means we have to connect and data should be handy in our hands and experts should see the data, and subsequently we should be able to maintain the plant and optimize the plant. So these papers will be in subsequent session. Just a brief how we are going towards digitization and automation. Coming to conclusion, so ultimately there is a roadmap towards zero concrete, at least concrete net carbon, which has been talked in first session. So there are possibilities of different levers. We can always use those levers. Then we have latest systems, CCUS, controlled emissions, and enhanced productivity methods. So you can depend upon KHD for all type of solutions to come to low carbon solutions. Thank you.
Thank you, Demlaji, for briefing us about the developments what KHD and HWI are trying to bring. The requirement of the time is to bring in all these modifications as soon as possible into the Indian industries that economical manner, whatever modifications we are proposing for digitization specifically. So once we do it on a economized model or some business model has to be developed on particular things. So we believe that, and we are looking towards our OEMs for better and better equipments with us, which can give us reliability as well as our enhancements. Thank you. So next is our Recuperate, Cool and Sustain ICANN by Saundararaj.
Good evening, ladies and gentlemen, and thank you for NCB for organizing such wonderful seminar. And it would have been even better, we would have postponed this session for tomorrow morning. So already people are very tired and the chairs are getting empty. So let me start with the basics before I get into the details. The basic function of the clinker cooler is to recuperate the heat back to the kiln and cool the clinker with the lowest power. When things are like this, but your operating team is asking for a second capex for this cooler after 8 years of operation and so on. And why it is so? Due to the deteriorated energy levels and the fuel cost is going up day by day, which is killing the operating team, which is they are forced to ask for a second capex. We believe that an equipment, if you install, it should be operated for 20 years with a sustained process results as guaranteed. So another important criteria for a clinker cooler is sustain the performance for a longer period of time. So to sustain the performance, the equipment should be built with strong fundamentals. ICANN strong fundamentals are KITS 4.0, Conda effect, LPS wireless grade suspension, and a simple drive. And now, whether the clinker is getting finer and finer, yes, it is. We have a lot of challenges going ahead, that our targets are very stringent to substitute green fuels, low calorific value fuels, and so on. Then when the challenges are, challenging target is ahead, and watching towards the challenging target also with a lot of hurdles. So how to handle these challenges? ICANN is introduced with a strong fundamental kits to the cement industry in 1980s. And now ICANN is fine-tuning and also getting ready, already ready to handle the challenges which is going to come. Like this, ICANN KITS 4.0 has the 4 basic and important features, like hybrid aeration, dynamic transport segments, variable slope, and based on the proven concept called Conda wings. So what is this aeration scheme of KITS 4.0? It has dedicated fans and with combination of both air beam and also through a chamber aeration. The landing zone will have a dedicated fan with beam aerated, and the center zone will have a chamber aeration, and which is helping you to move the boulders or agglomerated clinkers together with fines. It is typical for Indian kilns. Majority of the Indian kilns you have boulders and agglomerated pieces of clinkers and also too much of fines. So when such situation is there, you need to have better control in the static inlet to distribute the clinker. The clinker, when it is leaving the static inlet, should discharge uniformly to the following grade. That's what ICANN is keen to aim at the distribution. The center zone aeration is helping to distribute the airflow, distribute the clinker by creating a valley instead of a hill. So your red river is pushed to the center of the kiln, center of the cooler, though it is, you have a mixed clinker with big boulders and also fine clinker. The next is the kits. ICANN initially introduced the static inlet in 1980s to the market. saying the static inlet concept is essential for the better recuperation. Later, everybody has followed the same technology. And now ICANN says you can move the kits as and when required. Why we should move the kits? Snowman. A snowman is the biggest enemy when you have a challenging operating condition. In some special cases, typically for Indian kilns, you have a liquid content between 29 to 32%, and consistently, which is disturbing the operation. When there is a snowman, it's a prolonged upset condition. And the industry says, use air blaster, increase the number of air blasters, or you should have a specialized air blast nozzles. So, but ICANN principle is different, and we say big no for the number of air blasters, increasing the number of air blasters. The continuous compressed air purging into the cooler, which is not a good idea, and it disturbs the kiln process and disturbs the clinker bed, which is prepared in the static inlet. That's why ICANN says a selective area of the kits can be moved, and ICANN 4.0 can be equipped as an optional feature with movable kits, that is IMD inlet motion device. The selected components are connected with a small drive element, and which is underneath. So this can be fitted also. This is not an essential feature because the snowman is not a regular affair in all the kilns. Only few kilns has such a regular affair. In that case, this can be fitted at any point of time. And the kits is doing the recuperation part in a better way as much as possible. And what is the pendulum suspension? The pendulum suspension role is that it need to maintain the zero position of the mobile structure for the longer period of time in the same position. So what is the advantage of it? The thing is, the secret of clinker cooling is the gap management. It maintains the gap uniformly, and thus your great resistance is also uniform, and the air is passing across the width uniformly without bypassing through any unwanted gaps. So this helps you to maintain and sustain the efficiency, cooling efficiency for a longer period of time, despite the cooler is getting aged. And if you look at the cross-section of the ICANN bit, it will have fines at the top and cores at the bottom, the stratified layer. The stratified layer is getting prepared in the static inlet itself, that is the kits, and it is getting uniformly, it need to get uniformly transported till the end of the cooler to have the better efficiency. What is the advantage of this? The coarser clinker will have lesser heat, the fines will have larger surface area and more latent heat, and thus you have only limited period of time for the recuperate the air. Within the given time, you have to recuperate as much as heat possible. So this stratified layer is very essential till the end of the cooler. So when ICANN kits preparing the stratified layer, it has to go unmixed. There should not be any mixing when you are conveying the clinker till the end of the cooler. So ICANN had earlier a special hydraulic drive to simulate a slow forward and a quick backward motion, which was transporting the clinker which is prepared in a stratified layer till the end of the cooler. Now, with the latest VFD technologies available, we are able to make this drive even very simpler with a simple geared motor and a VFD drive. This is what you see, that a small local control board and a geared motor, and within 100 meter, there will be a VFD to drive this geared motor. That's it. This is the drive, which is located completely outside. This overall view of the ICANN cooler looks very simple but powerful. If you look at this, the green zone is your very open area. The drive is outside completely. The red zone is the inside chamber, which has no active components inside, like no lubricated parts, no rubber hydraulic hoses, no oil pipes, and there is no instrumentation, no hydraulic elements. This makes ICANN easy for hotter recirculation, and this helps you to enhance your green energy production without any reliability issue in the cooler. One of the important case study which I would like to share here is Dalmiapuram's ICANN cooler. In 2006, originally this plant was installed. Actually, this was installed with air beam technology, and this air beam technology cooler was deteriorating in energy. Then finally, they are forced to they are forced to hunt for a better energy efficient cooler to maintain the energy on sustained basis and to become more energy efficient. So ICANN was the result, and this entire cooler was supplied, commissioned, everything in the pre-assembly, everything was completely done during the pandemic time. And this cooler, with the quicker modular assembly kit, we were able to erect with 18 days access to access. And if you look at the performance, the clinker can be hand touched when it is running at full production. This is 40 plus ambient temperature to get this 40 plus ambient, only 3.85 units of power was needed, and 116 kilocalorie at 0.8 nm³ per kg clinker was the cooler losses which was achieved, which is equivalent to 86 kilocalorie kg per kg clinker at 1.15 kg of standard cooler loss. So this is one of the benchmarks IKN has set. Similarly, IKN has set various benchmarks like lowest power, lowest energy efficiency.
Yeah, any issue?
IKN has set various energy benchmarks like various lowest power, lowest energy, highest energy efficiency, lowest cooler losses, and highest reliability. And like this, there is another important benchmark is sustainable results for more than 20 years. Like if you look at this plant, this RS Mehta cooler was initially installed in 2001, and the PG test was done in 2003 with all the guarantees achieved. And even if 2019, before pandemic, we had an audit, the energy efficiency is same. The standard cooler losses are 88 during the PG, and now it is 87 kilocalorie. And with the VFD, the power of the cooler fans have come down to 3.1 units. So this was a remarkable achievement. For the last 20 years, this cooler is still outbeating the latest generation coolers available in the market. Further, Ultratech cement, if you see this, Rajashri 4 and Ravan 2 was installed in 2013.
We have to conclude now.
Yeah. 2014, then this cooler is also performing like 87 kilocalorie normalized cooler losses on a sustainable basis. So thank you very much for your attention, and our customers in the world and customers in India are keeping us as a leader, with trusting us in the innovation and sustainability technology. And thank you very much. Jai Hind. If you have any query, please feel free to visit us at C84.
Thanks, Honorable Raj. We are thrilled to note 40-degree plus ambient temperature from the cooler. So certainly it would be a dream for all the plants. So we will keep in touch for that. Let's move to the next one, that is utilizing curved conveyor technology and for efficient long distance material transport, from Mr. Marcus Reebok, Beimer. Yeah.
Good evening together.
Good evening.
So today I will present the utilizing curved conveyor technology for efficient long-distance material transport and the combination for improving the environmental impact of the operation. So my name is Marcus Rehbock. In short, I'm with 25 years with Bäumer, and now I will come to the details. So Bäumer Group is a family-owned company, and here I would like to mention that we have a 50 years proven track record of bulk material handling when it comes to overland conveyor, and we built 1971 the first overland conveyor in the world. Here I would like to show you our global setup, and particularly in India, we are having 500 people plus here in Delhi, and with our own manufacturing setup. And here I would like to show you the portfolio from mine to port, and you may know us all in the cement industry for bucket elevator, packing plants, and apron conveyor, and today I would like to introduce the long-distance overland conveyor in particular to you. So when we speak about the today challenges, so where we can support you with sustainable operation, with reliable solutions, with safe operations for the public, environmentally friendly, and of course, is eliminating the huge number of trucks for the transport challenges. Okay. Now I would like to show you a small case study. This is a 42-kilometer overland conveyor, and here we have found a solution about 3 overland conveyor versus 10 short conveyors, and I would like to give you the top marks for this conversation and the outcome. So we're having here 4.5% of saving in CAPEX in the length of the belt, or 14% in the width. We are having a CAPEX saving of eliminating 7 transfer towers, and emissions are all a big theme, so we can help for the public living nearby, for the environmental approvals, land approval, forest approval, and CAPEX saving while utilizing overland conveyors in the electrical and automation package. Then huge power saving for the same task, about around 40%. And the operation and maintenance costs are also significantly lower while using overland conveyor versus shorter conveyors, lesser spares, lesser maintenance, lesser efforts, and higher availability. So I would like to show you one of our recent installations here in India. This JK Cement is in operation beginning of the year. This is a 7.4 kilometer single flight overland conveyor. And here you see some pictures, interesting pictures. You see the acoustic panels to reduce the noise. Even when you're driving the overland conveyor in the night, you will hear nearly nothing. And this overland conveyor here in the overview, you see all the challenging crossings what we're having, highway, the villages, the mine area. And I would like to mention that this project is the most challenging project for us in the Bäumer Group so far. And we assume in the world we're having the tightest radio of 650 in this project, extreme narrow corridor with 50 obstacles as mentioned here. And interesting is here the ROI is lesser than 2 years. So what do we take home? The sustainability will play an important role in the future, today and in future even more. The material handling concepts asked for modern solutions with environmental friendly, dust, noise, emissions, energy saving, safety, OPEX and CAPEX. So we can offer and we can support you with state-of-the-art curved overland conveyors as a better solution in many projects. And talk to us, visit us in our booth B39 to B42. Thank you very much.
Thank you. Thank you, Mr. Marcus, for a beautiful roadmap for your curved belt conveyors. Of course, ROW issues are there in India, or that will remain, particularly in the points and the times when we are running short of land now. So thanks, that will help us a lot and it will open up the eyes, but we are looking forward for how best it can be fitted into India and fast, so that it should be comparable with the normal belt conveyors. Thank you. So let's move to the last presentation of the session, that is clinker cooling solutions by Anurag Jauhari, that is from KHD and HWI.
Thank you, Chairman and Co-Chairman and all the delegates. Very good evening to all of you. Myself, Anurag Jauhari from KHD Humboldt Vedag, India, who will be presenting today about the Pyrofloor Square Cooler. It is not a new cooler. It was introduced to the industry way back in 2004 as a first generation cooler of PFC, Pyrofloor Cooler. And based on the operation of around 7 to 8 years and what are the problems what we were having during the operations, we further elaborated and implemented the developments and introduced the new series of our cooler as a PFC Square in 2012. So it is not a new cooler. It was way back developed in 2012, and the first cooler was put in operation to the industry in 2014. So here I would like to introduce, there was one comment from our one of the presenter in the today's session that there is a demand of second capex of after 8 years or 10 years of operation because of the deteriorated energy levels and the performance level. And here we at KSD want to give a statement that it is not a global truth that even after 8 to 10 years of operation, there is a demand, there is a requirement of second capex. And that is why today we are presenting this cooler not as a new, but over a long operational result and experience in the industry right from 2014 till today. So we at KSD, we are having any machinery which has to be developed based on the 4 parameters, which are, it should be high in efficiency, low in wear and the maintenance, and reliable, and last but not the least, it should be low in capex as well, because investment is also important, and total cost of ownership to the end user should always be keep in our mind. So keeping all these factors in our mind, we have introduced this PFC square cooler as a second generation cooler to the industry. So here are some of the developments we have done in the past and which are operating since last 8 years in the industry. One was the static grade development. The development was being done based on the new cassette design of the pyrostatic plates with the optimized aeration plates for the better heat recuperation, because we all know the static grade is the heart of the cooler, and the entire performance of the cooler is entirely dependent upon the static grade. If your static grade is well in, highly optimized and performing well, your entire cooler will operate well. So based on this, we have introduced these new cassette plates for the PFC square as a pyrostatic, which is well optimized with the aeration slots and with the low pressure losses. So not only it is recuperating better heat, but on the cost of the lower power consumption. So we are giving both the advantages with respect to the heat and the power. And during the presentation, I'll show some of the operating results of the industry, what we have achieved during the last years. This is one development. Second is about the aeration cassettes. Aeration cassettes are being also introduced right in the PFC square in a different module. Here you can see the earlier generation cassettes of our pyrofloor cooler was higher in depth for the more material loading, and the aeration profile was to the length of the cooler, which was later on changed to the lesser bed heights, lesser height of the cooler to reduce the pressure loss of the dead material layer over the clinker, these cassettes, as well as the aeration profile was also changed to the width of the cooler. And by doing this, there was an improvement not in terms of the power consumption, but also in terms of the reduction in the aeration demand, as well as improvement in the heat recuperation. So based on that, because it gives an impact on the slicing of the air across the width of the cooler to the according to the cooling curve of the cooler, which gives a better heat recuperation based on the statically designed aeration chambers. So this is the point 2. And second, to improve the reliability, as what we saw in our first generation cooler, was some of the dust fall through was there, even though it was designed and conceptualized as a zero fall through cooler. But based on the longer run of operation, we have observed there was some sort of spillage from the seals, because the design of seal was from the asbestos ropes, which was later on improved by the metallic sealing, which is S2S longitudinal sealing, with low wear, and there was a metal-to-metal contact, which ensured there is no any damage to the lateral seal, longitudinal seals, which avoids any spillage. And all these things which I am presenting here, that you will see in the later part of the presentation with the clear pictures from the plants from the last years, where you can visualize by yourself that how what we are presenting here is already we are executing and already we are achieving over there. Later on, there were more change in the support roller design also. Earlier, there was a normal support rollers, which was later on changed by the robust combination rollers for the improved life of the conveying of the lanes. So based on that, you can see by yourself that the pictures and the cassettes and the plates, we are having a longer run of operation. And you can see even after 5 or 7 years of operation, there is hardly any wear. And you can see underneath chambers also, there is no any spillage even after 6 months or a year of operation. And these are the results not a day or two or a year or so. These are the results of our 7 to 8 years of operation. And still we can see all the cooler plates as well as the ceiling as well as the rollers are well intact and giving the same performance for it was being designed. And here some of the results of some of the plants for the capacity ranging from 2,500 up to 6,000 TPD, we can very well see the power consumption and the recuperation efficiency is in the range of around 74 to 76%, and power consumption is in the range of 4.8 to 5, which can further be optimized based on the clinker cooler this cold clinker temperature with a slight increase if the end users feel that they can accommodate some more hotter clinker to further utilizing their grinding system for utilizing the wet fly ash or the slag or some wet material, which can help to get the more heat from the clinker to substitute more and reduce the heat demand from the secondary sources. So these are the results from different part of the globe, right from USA to the Turkey and Canada, where these coolers are operating since 2015 into the market, and since last 8 years, we are achieving these results on the sustainable and continuous basis. And there is one case study which we have carried out for the static grate only in one of the plant, where this was the design this was the concept which we have conceptualized for doing the static grate retrofit. The concept was like that, to improve the inclination of the static grate from 12% to 15% by horseshoe construction in the static grate, as well as the operation of the shock blowers, which is very, very important for the efficient operation of the cooler. And if you see, after considering all these base designs, what are the results which we have seen? These are some of the CFDs which we have carried out for the new static grate plates for reducing the pressure losses from first generation to second generation. And the results are like that. In the first generation cooler, in the static grate, the pressure was around 25 millibar, from 16 to 25 millibar based on different aeration inputs. And in the PFC square, on the same aeration inputs, the pressure loss was reduced to half of it, or we can say around 10 to 12 millibar, it was reduced. So that is very well evident by installing these plates, the power demand of the cooler has been reduced. And after the retrofit of the static grate in one of the plant, these were the results where we can see there was a drastic improvement in the performance of the cooler. There was a target of 7% increase in the production, which was very well achieved to close to 4,700 TPD. And the specific cooling air demand was also reduced, which has caused for the lower power consumption, as well as the clinker temperature was also reduced from 132 to 80 degrees centigrade. And there was a time of 14 days based on their local installation timelines. For India, we can see what best can be done. Maybe within a week time or so, it can be implemented, and we can get a results for improvement in the performance of the cooler. So this is all from my presentation, a very short one. And the more details, if you want, you can visit us at our booth at C56 for giving more details of our cooler and the further developments. Thank you.
Thanks, Anurag. We are looking forward for more innovations in the cooler.
Thank you, sir.
And reduction in the temperatures going forward. So with this was the last presentation of our session. Now I would request Dr. Meier to summarize.
Yes, first I would like to thank you very much for giving me the chance sitting next to you here on the stage. Also, I would like to thank the NCB organization for this wonderful late evening session. I would like to thank also the very inspiring talks of the different topics in the production of the cement. I think we all have seen here great opportunities, and before I want to explain you some of the details, but now seeing the time going away, I would like to skip this part. I would like to turn around the whole story. I would like to ask you to really go home, digest these wonderful talks, and pick the most promising opportunities for your on-site issues, because I think all these solutions are very, very relevant to improve the industry. And I'm very, very sure it gives you new opportunities. And hearing here that some of the ROIs are in the order of magnitude of only a couple of months. I think nobody should miss these great opportunities to improve and to save money, to save the environment, and to make a very good, consistent product. Thank you.
Thank you, Dr. Meier, and there is nothing more to summarize because as Dr. Meier has said, we have to imbibe all these information, and we are looking forward towards our equipment manufacturers to help us in attaining the net zero target, which is our dream. And their innovation, their continuous improvements in their systems, and something out of box is the need of time, which will help us in multifaces. So thanks once again, and whomsoever is left over with us, let's go to the home. Thank you, and over to...
Thank you, sirs, for chairing this session, very interesting one, on cement plant machinery and project engineering.
Thank you, sir. So I would now request Shri Saurabh Bhatnagar to kindly present mementos to respected chairman and co-chairman as a token of respect.